YouTube. So, hello everybody. As every Thursday, I'm solving coding interview problems. I'm kind of a pro if it's the first time you're watching me. So it's not that I'm learning something here. Just I'm solving problem, explaining my thoughts, and trying to teach you something. Hi Rohit, Dmast, Manan. How are you? Think you're muted? Are you sure? Am I muted now? I see that sound bar is moving in OBS, so you should hear me. All right. Any problem suggestions? Later I will choose problems just from maybe a recent Leetcode contest, but for now, the first 2 or 3 problems proposed, I will check them out and will choose one of them. Hi, Casablanca and Sayak Hill. Only Leetcode. If you have something very cool from binary search, then fine. What problem should I solve? What about something very well known? Sort list. Cave largest element in an array. There are quite a few solutions for that. Like there's one with log k where you maintain a heap. There is a random one. Maybe this. You didn't ping in Discord. Thank you, June Waves. I'm doing that now. Discord. Stream pings. Done. Largest rectangle in histogram, maximum product, subarray. I think largest rectangle in histogram is a good problem, and I think I didn't solve it yet. Character largest element was yesterday's January challenge problem. But you mean it's already over or it's still going on? No, another problem? Okay. Let's try this. I will put link in the chat. Here we go. How to make Socketio scalable? I have no idea what that is. Sorry. I do algorithms, nothing else. We are given heights of columns, vertical columns, and we need to find rectangle of big area. Find the area of largest rectangle in the histogram. If you don't know that problem yet, now's the time to think about it. And first I will give you a hint that we will do more than one solution. But a hint is that in this drawing, minimal column is very important. There, one type of rectangles we should consider is the one containing column of height 1. If you contain column of type 1, there is no reason to stop anywhere else than at ends of the whole drawing. So this is area, possible area of 6. And then when you want to move on and consider some cases not containing column 1, then you go recursively to left part and right part. So consider this, consider that. This is one of possible solutions. The best one is actually linear, and we will get to that one too. But I think this is more intuitive if you know proper techniques. Right? This is a hint. think how to efficiently go recursively to two parts. Either rectangle will contain the minimum, or it will be strictly on the left or strictly on the right. In particular, if minimum is always in the middle, that will be n log n, and that's very good. How to deal with cases not being exactly in the middle? Think about this. This was a hint. And in the meantime, I will try to add some overlay. Can we use a segment tree? Try not to. Yes, this problem can be done with a segment tree. Actually, I need to know. Maybe I will ask some people working at Google and so on. What happens when candidates try to use a segment tree? Can they be asked then not to use it? Because, by the way, yeah, I would solve this with segment tree, for example, as well. And that would be n log n anyway. But can there be a question like, okay, do it in the same complexity, but without a segment tree? I don't know if that happens. I'm not accepting new problem proposals now because we will for some time focus on largest rectangle in histogram. They would appreciate, advanced things, but coding interview isn't about that. If I wanted to hire you for my company, no matter if it's a small or big company, I wouldn't care if you know a segment tree. I would care more if you know how to think and solve kind of easy problems. It's better to know segment tree than not to know it. But if I saw two people and one would solve a problem with a segment tree just because they have a huge experience with competitive programming and the other solves with some other technique, I think I would prefer the latter. Is that a video? That's very interesting. I want to hear this. It's not muted.
Sort. Thank you for watching this. Hello, welcome to today's Leetcode video solution. We're going to be looking at the merge intervals problem. The problem here for a grand total of O n log n for the time complexity. Let's see what this looks like in the code. Now remember, the first thing we want to do is we want to sort our given array. We can do that by saying arrays.sort. Thank you for watching this Leetcode video solution.
All right. I'm very surprised. This is not the topic for today's stream, I guess, but in general, I'm interested in this field of coding interview platforms like AlgoExpert and Leetcode. And it's the first time I'm seeing a video on Leetcode. Is it a new thing, or this is a very old problem, 84. It's from years ago. And I'm not here talking about whether explanation is weak or not, but this is exactly what AlgoExpert did, and it's how they are different from Leetcode. They, first of all, have videos with this conceptual part and code part. AlgoExpert is exactly about the videos, kind of nothing else. It's exactly videos. What percentage of problems in Leetcode now have videos? Can we solve using two pointers? Not really, because the idea of two pointers would be to deal with some interval. Let's say that you're considering some interval like this one with 5 and 6. Which pointer do you move? Do you move with right pointer to the right? You cannot decide. You don't know where is optimal one. Almost always you use two pointers where, for example, you want to find shortest substring containing all characters, let's say. You have a string A, C, A, B, E, D, E, A, and so on. And then when you consider some substring, and you want all characters to appear, and we say, oh, okay, not all characters appear, so I need to expand my interval. So I take another character. If you have enough, you shrink. You can use 2 pointers with moving some kind of window, but not necessarily of constant size, only if you're able to say if you should expand or shrink. Here you cannot. So 2 pointers isn't a good idea. Pointer at start and another at end. Okay, but which one will you move? Just looking at height of the first column and last column, they will not tell you where you should go. Depending on other values inside, between them, maybe the first column is good, even though it's shorter. Imagine this case, where the first column has height 2, the last column has height 3, so you might think that the last one is better, but there are here a lot of 2's, or maybe a lot of the bigger values too, and here there is a 1. If you try 2 pointers where you move left pointer or right pointer towards the middle, and you get rid of the lower one, which seems reasonable, that's not good. There is a similar problem that we solve with 2 pointers, and it is quite surprising. I don't remember the title, maybe one of you remembers, but it's the problem where we have bars. We need to choose 2 of them, and then we say that minimum of, we put water here, and we maximize the amount of water here. This is solvable with 2 pointers, but it's not really intuitive. Is this convex with target rectangle height as input? I don't know. Container with most water, exactly. It's not trapping rainwater. It's this one. Container with most water is a problem that you can solve with 2 pointers, but I would say it's a very bad coding interview problem because it's such a crazy thought. I solved thousands of problems, and I wouldn't here think that you should use 2 pointers, so I would say it's very counterintuitive. Anyway, let's get back here. All right, let's see some solution of largest rectangle. Right. One method would be to always know where the minimum is, and recursively go to the 2 parts. Like after considering this minimum, go here, go there. So consider this pseudocode. But pseudocode will show us what do we need there, what method do we need. A recursive function that gets interval from L to R. And what does it do? Well, it considers rectangle, so answer is maximized because we maximize the area with what? Minimum height times the length, R minus L plus 1. Min is find minimum from L to R. Maybe it is possible in some way. Answer is this, and then go recursively to from L to minimum minus 1. Actually, here we mean position of minimum. And right part. And of course, we need to break from interval, like return from a function if it's empty already, or the interval length is 1. This line with answer, it just says that if I see that the lowest column has height h, and the width of this is w, then I consider height times width as the answer. This is height, this is width. All right, and now if the data is random, if the sequence isn't for example, sorted, but it is random-ish, then this is n log n. And it's quite common, like, for example, merge sort is n log n for the same reason. Assuming that this part we do in linear time. How to find minimum in interval? You can go one by one and find the minimum. If you do this, then this is linear, but then you go recursively to two parts. And it's quite well known that if you do something in complexity n, then on average you have n over 2 and n over 2. Then you go even like more down with recursion to parts of this size, with this complexity, n over 4, and so on. This totals to n log n because every row sums up to n and there are log of n rows. This sums up to n, this sums up to n, this sums up to n. So if depth of this recursion is logarithm, everything's fine. I will here talk about segment tree. Can we binary search on answer for this? We can, but I don't think it will make anything easier. And yeah, there are ways to speed this up. I would say that the most standard in the world of competitive programming is to use a segment tree. With a segment tree, this you can do in logarithmic time, and this line in total will be run only linear number of times, so it is n log n in total. Because the number of nodes in this recursion is n in total. And now what I'm doing, if I want to use a segment tree, is I'm replacing everything. Instead of complexity n here, I have complexity log of n here. Instead of n over 2, I have log of n over 2, which is still log of n, and so on. Then what I have here in total is n nodes in this, let's say, binary tree, each giving me complexity log of n. So n log n in total. But that's a segment tree. And then a problem is already done. It's all cool. Can we do something else? Oh, by the way, if we want to again go into competitive programming field, then this can be used as well with sparse table, even better, even more straightforward. Then it's in constant time after proper preprocessing. Still, the total complexity will be n log n. Sparse table is an alternative to segment tree. So those are solutions I would use, but not everybody knows those techniques. Does sparse table have any limitations? It has n log n preprocessing and memory usage. So, it's slow preprocessing to answer queries fast. If you want to read more about it, then just, use Google. I want to move to a solution that here is expected from candidates. What else can we do to find minimum? Well, to find minimum, we can in particular sort all elements, right? If I sort, I will get 1, 2, 2, 3, 5, 6. And maybe that helps in some way. And let's say that when I sort, then also I remember positions. So I sort pairs, value, comma, position. But yeah, I have a sort. 1, 2, 2, 3, 5, 6. Sort can be done in n log n, and it's much easier than segment tree. I look at the first minimum. I look at minimum, which is the first number in this sorted sequence. I consider that as height of a rectangle. Then I will have this rectangle. Then I have those two smaller parts. So, and this is already kind of blocked. When I consider the next minimum, let's say that a tie was resolved in such a way that this is the next minimum. This 2 on the right. What rectangle does it give me? I should in some way find this rectangle. This one. This means that for now a new value, and next to this value, let's say that I also know position. this is position 5, if I index from 1 to n, because this is column, 5th column. Well, I want to know in which recursive part I am right now. 5 should understand that it is an interval from 3 to 6. Initially, I have everything from 1 to 6, then I consider the minimum, column 2, and then I have part 1, 1 and 3, 6. So maybe I should maintain those intervals. I should say that first I have from 1 to 6. I have minimum somewhere, I know the length of this interval, then I have from 1 to 1 and from 3 to 6, and this will break down into smaller and smaller intervals. You can say that this is some kind of a tree, if you want. So then 3, 6 would break into 3, 4 and 6, 6. This is one way to look at it, this kind of breaking down of intervals into smaller intervals. Or a bit easier, you can say that there are some already processed columns, like at the beginning, like this one we forbid first, or process first. And then when I consider some new minimum, a 2, I want to know where was the previous smaller value and next smaller value. So 2 already processed values. When I consider this 2, I want to know that previous smaller value was here, and next smaller value doesn't exist, so let's say it's here. I can add fake -1 at the beginning and at the end. Where is the question? It's this one from Leetcode, and also link is in the chat. Link comment. Largest rectangle in histogram. Right? And now if for every number I know that for column 5, the previous smaller was column 2, the next smaller is imaginary column 7, I know that this is interval from 3 to 6. So new code or pseudocode is actually for every position, and luckily for us, it doesn't, the order of considering that doesn't matter. For everything, let's do more pseudocode style. For C from 1 to the number of columns, we consider previous smaller, let's by X denote, let X denote previous smaller, Y denote previous next smaller, that would be here 2 and 7, and then answer is max with what? Value height of C, height of this column, multiplied by length of interval. This is Y minus X plus -1. Let's think. From 2 to 7, the difference would be 5, but actually I want 4 columns, so this is -1. Right? This is new code. If we know this, then we can solve a problem in linear time. Hi proxyking. And I'm Storm prod code. Right, and this is quite standard also in coding interviews. I'm sure that many of you encountered this problem. There is a well-known method solving this, and it is, I think, the only method to solve this problem in linear time. Chat, do you know how to find this in linear time for every element in a sequence? The problem boils down to, for every element in a sequence, find previous smaller element. Using a stack, exactly, monotonic stack. So with this experimentation, even though we moved through a different solution here, something we've kind of divide and conquer, something like that, this way we figured out what we need to use. Just because I wrote a solution in a different way, still inefficient if I want to find each of those separately in linear time, that's quadratic, but I now recognize, oh, this is a well-known problem, I know how to do it in linear time. Yeah, we use stack. when going from left to right, so when moving in one direction, we can find previous smaller, and then I would reverse a sequence and run the same algorithm again. Then I would find this array. Now, for those of you who don't know how to use a stack to solve this, we are solving this problem. For every element in a sequence, find previous smaller element, the most recent smaller element. This is the idea. If we have 3, 6, and then there will be some new element here. If it will be, for example, 7, then 6 should be remembered as previous smaller element. If it will be 4, then a 3 should be remembered as previous smaller element. And if something smaller than 3, then let's point to imaginary element on the left, like minus infinity. Maybe it's good to just assume that here, as the first element, we have minus infinity. So everything would point to something. Right. Now, assuming that we have this situation with, let's say, a 5, it points like that. We remember that 5 knows that the previous smaller element was on this position, because actually we want to remember position, not the value. Then when there will be some new element here, there will never be this edge. 6 will never be previous smaller element, because 5 is better. If this element is bigger than 5, 5 plus, then it will be like that. If smaller than 5, that it will point to 3. What does it mean? It means that we can forget about the 6. We will always maintain a few, actually a lot of them, but we will maintain some increasing sequence. Like this. Let's say minus infinity, 3, 5. Let's say that later we got 8, and also we got 20. What happens now if we have 7? Well, if it's increasing, your first thought can be we binary search. Yes, we can. That's unnecessary, but we can. We can binary search that last value not exceeding 7, like that. But then we would remove this part, because we know 7 is better than 8 and 20 for every future value. In a moment here there will come 15. 15 will point to 7. 8 and 20 will not be the previous smaller element for anything new. And because we remove this part anyway, instead of binary searching, let's just do this. 7 always checks the last element. If it's too big, remove it. Check the last element. If it's too big, remove it. Check the last element. If it's here not too big, keep it this way. This is a stack. Always when new element comes, pop the last element as long as it's greater than new element. Link not working? Why? Oh, link just has some cooldown. The link comment in the chat. And everything is linear. We don't even need binary search. Even though it makes sense. I can imagine some people just, not thinking about this tiny detail and thinking that, yeah, we do stack and binary search at some moment. No, because we need to remove anyway, we don't use binary search. And everything is O of n. And this is how we are able to compute those values in linear time. So also the whole problem is solved in linear time. Because we do it this way, you can get some even better understanding of what happened and kind of directly solve the histogram problem without remembering those values. For that, let's have slightly different interpretation of this. I don't know if I want to go into that because it will take me another 20 minutes. Or should we move to the next problem? Because while we remove this like that, let's try to be brief here. There is a 3, there is a 5, 8. I know that scale isn't good here. 20. Also, there could be some numbers in between that we already removed. And now there is 7. So what really happened is that when 7 popped 20 and 8, we should consider this rectangle. But also when removing some other values like this, maybe not this way. When removing 20, we should consider this rectangle. When removing 20 and 8, we should consider this rectangle. There is something like this going on, which means that as we do this, we can compute the answer for a rectangle problem as we go. We then can get rid of this part, because as we compute pref smaller, actually we can also compute area of rectangle. But I think let's not do this. So let's make a vote whether we should go deep into understanding or move to another problem. Both make sense. Can you talk about merge sort I talked previously, but not now? So as you pop, you indeed compute area and keep going. Yes, sorry, I will make a poll because the chat is quite active today. Straw poll. I see a lot of messages. I see, but I think it's quite even. And sadly, because I'm not a Twitch affiliate, I don't have an option to make a poll in the chat. Come on. I have internet? I do. Don't tell me that straw poll is broken. This is not my straw poll. No. Does it work for you? Is it down for me? This is a very cool service. If some website doesn't work for you, go to down for everyone or just me and check if it's you. Paul makes a poll. I don't think so. I will try. Yeah, I recommend this command. Maybe my bot allows that? Yes, trouble me is down. Maybe stream elements can do that. This is bot I'm using. There is something like that. Or not? Oh, want to have. No. Okay. There isn't. The other website is also good. Okay, strap the other strap hole then. What? Here you go. Stream is great, Puggers. Thank you. Just use this overlay. I can consider it. Anyway, I gave you a link to Stropple, but I will check this out as you vote. I understand that now it would be faster to just do something, but as a programmer, I prefer to spend 5 minutes once to make it more convenient later. Separate, yes, no. I don't know, please let me go. Missing options? What? Why? Should I? Something is wrong. I need to connect my Twitch account, shouldn't I? I don't know what I'm looking at. Let's move to the result. Yeah, just 20 seconds. Why have you closed YouTube chat? It's hard to read messages even from one chat. So really, I understand that it's more convenient for you to be able to comment on YouTube too, but just I wasn't able to read messages anyway. So that's the reason. I don't know what am I looking at. I don't see how this connects to my Twitch account or anything like that. You can tell me. I will check it out later. All right, what are the results? Results. Another problem. Let's go to another problem. I won't be surprised if in editorial for this one you will find what's needed. Why do you have to? Maybe there is some solution written here. Yeah, I need to repolish my streams, and that includes also stupid thing in form of thumbnails in YouTube, because I just copy paste the same stuff and it's a bit bad. All right, I'm reading the chat for new problems. You can just suggest something now, just other than the link, tell me something about it. Like why should I do it? Is it hard, easy, what topic? Why chemistry is there? It's not that I designed my background. It was this way. Chemistry is cool too. All science is nice. Count of smaller numbers after self. I know how to do it in a segment tree, with a segment tree. How to do it without it? Can this problem be solved without a segment tree? Also, regarding the previous problem we were doing, one more solution is to maintain a set of blocked elements, blocked positions, and also something else, so set in C++, and also you can go backwards and use double linked list. This is an interesting fact. It's the only competitive programming related, let's say, problem I know where double linked list is useful and can lead to linear time. Monotonic stack isn't the only way to solve that problem, but that still assumes that you sort numbers. You need to sort first. But sometimes numbers are small enough that you can do it in linear time. Seems like DP in directions. I don't want this kind of standard DP today. No description, I'm skipping. Domino and Tromino. This will be hard. Swaps. Maybe. Okay, I'm focusing on. Oh, I see. This is SPY. I'm focusing on Leetcode. Does Google offer you a job? Not automatically. They invite for an on-site interview, and likely I wouldn't have troubles passing through that. Hire someone? Yeah, but it's all about deciding how it should look like. All right, let's choose one of those proposed ones. Please somebody tell me if this can be done on any other way than a segment tree. If yes, I will try to do it. Freedom trail. Too long statement. 2x1 domino or L-shaped domino. How many ways there are to tile a 2x n board? We can. Minimum adjacent swaps for k consecutive ones. We can. 2 keys keyboard. I'm choosing a problem. Once I'm done, I will give you a link. And I will tell you which problem it is. Character A is present. Copy all. Paste. Too boring, maybe. Yeah. And that's it. Cave largest was suggested earlier, and max product or something I remember was suggested a long time ago by Skier, I think. This thing. Don't I have a video for this? YouTube, not YouTuber. Maybe not. That's a different problem. Anyway, I think we can do this one as something easy, and then next minimum adjacent swaps. That's the plan. I like short statements, yes, and especially I like them for the sake of streams. For streams, it's very important that when you join a stream, you don't need to spend 3 minutes just understanding the problem. Right. You're given a binary string with zeros and ones. You need to get k adjacent ones, like k consecutive ones. Here, if we have 1, 0, 0, 1, 0, 1, and case 2, I need to bring two ones together. In one operation, I can, in one move, I can swap two adjacent values. So here I could, for example, swap them, and I would have two adjacent ones. If I wanted three ones together, I would need to bring all of them to each other. And maybe it would be optimal maybe to put them on those positions, maybe here, but something like that. Can be solved without sectree, can be solved using try. This thing? I mean, try is exactly segment tree. Okay, not exactly. It's a segment tree built on values. Is that their solution? Actually, I'm just curious. But anyway, I'm going with this problem, so grab a link. Right? The link command will work now. Order statistics from reverse order. Yeah, but you're talking about some very complicated structure available only in C++. Order statistics is not something you should use in a coding interview. What if some other interviewee tried to solve a problem in Python? Then you shouldn't be rewarded for your knowledge about particular very difficult structure you can use in C++, I would say. Let's try to do stuff without BST or anything like that. Ordered set, I don't know how it's implemented. I would guess it's balanced BST or some kind of red-black trees. Let's make drawings. Why? I thought this should move together. Okay, now it does. What if here I want to grab 3 ones together? Is it better to move them here, maybe there, maybe here? I just know that 3 of them should be together. Maybe that's hard to decide. And it's not that I can try every option. Let's think about it in a bit different way. What if string is longer? And now I want to bring 3 ones together. And the first option is that those I will bring together. That's option number 1. What's the second one? These 3 I bring together. For sure, it's not that I want this one, and this one. Of course not. I don't want gaps. It's easier to make a consecutive triple with consecutive ones if we skip zeros. I don't know if it's worth writing down, but idea, something like sliding window on which k tuple of ones I bring together. By the way, I don't know how to solve a problem. It seems easy, and I'm guessing that we should move this way. Probably put indices in a vector and then work on that. Yeah, seems convenient. Indices are 0, 1, 2, 3, 4, 5, 6, 7, and so on. Then indices of ones are 0, 3, 5, 6, 9, and 10. And I can take those 3. This now it looks more like a sliding window of constant length. Or those 3, or those 3, or those 3. But something even better is what an operation described in the statement does with this sequence of indices of ones. When we swap a 0 with adjacent 1, a 1 changes index by 1. So actually, we are able to decrease or increase in some index by 1, from 3 to 2, or from 3 to 4, assuming that 4 is the next item is 0. In other words, if this was yellow 4 already, an index of a 1, we couldn't make this operation. The problem becomes, you're given a sequence of numbers, they are limited, they are from 0 to n, and it is sorted. In one operation you can decrease or increase the number by a single number by 1. You need to make 3 values consecutive. Here it's easiest, I think, to change 3 to 4, and then 4, 5, 6. We're done. We're given k, the length of this tuple. It's not always 3. K is this thing from the input. How big interval of ones do I want? Aren't you bored of being able to solve all the problems? And think about teachers in school where they teach the same stuff for 50 years. I will be bored after 50 years of this. This stream, I teach during this stream. I'm doing that for a few years, let's say, any kind of teaching, not only on Twitch. So for now, I'm not bored. I'm still finding new interesting ways to talk about intuition behind some problem. Like in the previous one, the one where we say that some values are will never be useful as the previous value in the previous smaller problem. It's interesting, and most editorials, most solution descriptions don't say that properly. It's cool. It isn't that boring. Maybe it would be boring for me to solve this problem, but it isn't that boring to describe a solution. Not only the number of zeros between ones will be important. I think Madruga now suggests something like that in the chat. What is my salary? What is your salary? I don't have salary. I don't have a full-time job. But you can tell us your stats. All right. Let's see this example. If we have yellow indices 3, 6, and 9 versus 3, 8, and 9. The number of gaps between them is the same. Oh. Actually, it is the same. The answer for these two is the same, because we need to make here plus, twice we need to increase 3 by 1, that it will be 4 then 5. Twice I need to decrease 9. In this other case, I need to do plus, 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 right? 4, 5, 6, 7. It is the same. In both, I need 4 moves. All right. This, I thought that we will need to bring them to their median or something like that, but it seems that the number of gaps, the number of zeros in between matters. And because I noticed that now, let's prove it. We claim that if there is some, in the original sequence, if there's something like this, and we need to bring all those ones together, the number of moves required is equal to the number of zeros here. That's not true. Hey, that's not true. What about this? Versus, I think that this second case needs 4 moves, and the first one needs 3 moves. So it's not just about the number of gaps, or so also the distance between the first and last one. It's more complicated than that. What now? Median was my first thought because it's very common that when we have a few points and we need to bring them together, they need to get to the median. Second needs 5? I don't think so. This one will jump over 0, then jump over another 0. Then this one will jump over 0 and jump over another 0. This is 4. Remove a 0, you need as many moves. All right, Ario says something good here. For every 0, we can count how many times it can be jumped over. But then we would need to decide from which side we want to do this. Like if you have this string, is it obvious for you, for this 0, whether we should bring all ones to the left of it or to the right of it? I would say it isn't obvious. But yeah, that will work. So let's look at this string. For every 0, I will say this. This 0, either all those ones, 5 ones, will jump over it to the right, or this single one will jump over this 0 to the left. The latter seems better, so I will say there will be one jump like this. What about, let's say, this 0? Either 2 ones will jump over you, or 4 ones will jump over you if you want all ones to bring to the left from this 0. So now from the left seems better. But if I write down all possibilities, like here it will be 2, 2, 3, 5. And if I move to the left, if for a 0 I want to say all ones from the right, I want to transfer to the left, then it will be 1, 3, 4, and 4. What's very important is that both these sequences, 2, 2, 3, 5, and this thing, they are monotonic. And they meet exactly at median of ones. In this case, because I don't claim that always there will be this exact tie, but here we have a tie. And what happens is we need to take prefix of this first sequence and suffix of the other. And that will represent that all ones from this right part, they move to the left. All ones from here, they move to the right, and they will meet in this case exactly here. You can as well say here, doesn't matter. This one will not move. So we had sequences 2, 2, 3, 5, 4, 4, 3, 1, and I did this. In some other example will be that. For every 0, I count the number of ones on the left. So what happens if I want to make a meeting for ones to be on the right? And some other example might be that the sequence of this moves to the right required for every 0 would be, let's say, 1, 3, 4, 4, 7, 8, 9. And the same sequence for moving to the left is, let's say, 10, 8, 8. Actually, can they be different? I think they need to follow some kind of pattern, like the differences must be the same. It doesn't matter too much. 7, 7. Okay. Let's say like this. Then I would say that the meeting point should be there, and I will move those. I will use these values of what is the cost of moving to the right over this 0 and that stuff. The answer here will be 1 plus 3 plus 4, 4 plus 4, 3, 2. The sum of those values. And I was talking about these differences. Like, this is not an arbitrary sequence. This increased from 1 to 3 because apparently there were 2 ones in between. Like, look at this. 3 increased to 5 because there were 2 ones in between. Because we count ones on the right. And it also means that 1 here increased to 3. So the two sequences, that they match in some way, like 2, 4. The sum of those two values is always the same. 2 counts the number of ones on the left. 4 counts the number of ones to the right. Well, the total must always be equal to the total count of ones. Here, 6. This is why I thought for a second, after writing down this sequence, can I choose arbitrary second sequence? I cannot. Everything must match. So I wrote down here a case where there are 11 ones. The sum of every corresponding values is 11. Sorry, didn't understand what you said. I'm saying a lot of stuff. Maybe I will do some recap at the end. Long story short, if for every 0 I count ones on the left and right, some prefix of zeros will have few ones on the left, so it's better to move to the right. And this way, opposite stuff for the suffix, and this way I will find some kind of meeting point for ones, optimal meeting point. And this is all equivalent to saying that one that is a median should be taken. Because this is where the values swap, like from this 2 was smaller than 4, and after, those 2 ones are medians. After that, everything on the right will satisfy that this value is greater than that. One more example. For this example, I claim that this is the best meeting point, because in this case, this 0 will be jumped over 2 times. Those 2 ones will jump over 0. This 0 will be jumped over once. This 0 will be jumped over twice. This one and this one. And same here. I claim that for this test, the answer is 7. The sum of red values, 7. If I said that meeting point for ones should be in some other place, like maybe here, should be meeting for ones, that's worse, because notice that I made those 3 ones to travel more. And I made it closer for those 2 ones, but more ones need to travel more. And in this case, so for this, the answer is 7. And for this worst case, the answer is what? This will be 2 plus 3 plus 3, that's 8 already, plus 1, 9, I think. It's a well-known fact, median is best for meeting of multiple things, if we just care about sum of distances. And I'm assuming here that k is equal to the number of ones I'm looking at. Also, median, there are 2 medians if number of ones is even. Actually, and anything between them will also be a good meeting point. What is the proof of median being optimal? It's more common in this case. Imagine there are 5 points. Those are friends who want to meet up. This friend only has legs and a head because I don't want to draw more. I claim that this is the best meeting point, no matter how far away those guys are. Look at this. If this is a meeting point, and it has some total distance, let's say 55.70. This is the total distance. This plus that plus this plus that. Let's say each of them needs to drive a car and we care about the total amount of fuel. Now, if I shift this to the right a little, and this is d, the distance by which I shifted is d, then each of those 3 guys, they need to travel extra by d, so the answer is increased by 3 times d, and they save d distance, so minus twice d, but still I wasted something. This new distance, the sum of distances, is bigger, assuming that this is distance d. Same stuff if you move the meeting point to the left. If you move meeting point away from more people, you're making the total distance worse. It's the same. All right. But we didn't solve a problem. Also, now I remember that I wanted to do this first. Sorry about that. Whatever. Okay, the median. Yellow sequence was a sequence of positions of ones. Now we know what median is, the middle element. If k is equal to 5, and this is the sequence of positions of ones, then I have a choice of making those ones meet, and then they will meet at position 5. Or I need to make those ones meet, and they will meet at position 6. I see how to maintain, how to quickly compute this thing, but I don't know how to do it easily. How I would do it. Well, I know that apparently their final positions must be 3, 4, 5, 6, 7. 5 is median, they will meet exactly there. Everywhere else needs to get close to that. But it would imply some complicated computations. 0 to 3, 3 to 4, 6 to 6, 9 to 7. I cannot in linear time compute this, go element by element, because that would be quadratic in total. We don't want n squared. But n squared would be good if we could, every sliding window, every possible window placement, if you could consider in linear time. Which problem is this? This link. So we don't want that. We can maintain some kind of prefix sums, some kind of information about this sliding window. I will get to this solution with prefix sums, but first I want to try something maybe easier. I don't know the best solution, I'm trying something here. And maybe let's try to think still about these zeros. I don't know if it's a good idea. Maybe. So this first sliding window, it represents interval from here to there, with a meeting point being this middle one. Also, let's get rid of those dots, right? This is the first sliding window. Later, we need to move it to something like that. And now either I need to focus on every one and compute how much distance it will cover, or I need to look at every zero and say how many times it will be jumped over. One of these two approaches. I'm not sure which one is better. Let's investigate this thing with zeros. This zero will be jumped over once, because it will be jumped over by this one. Once, twice. For every zero, count the number of ones on the left. Those need to jump to the right. The opposite stuff here, 1 and 1. How many ones need to travel from the right? If I compute the sum of red values, it will give me 6. 6 is a possible answer. How does it change if I move to the second interval, possible interval from here to there? Well, I believe that each of these values gets decreased by 1. In particular, can become 0. Because we got rid of this one. So the number of ones on the left that need to travel to the right, it decreased. The meeting point is now here. And also interval is like that. What else changed? For those zeros, their counts increased by 1. So it is now 2 and 2. So maybe what I will need to do is, let's try to make it more general. When I have some sequence of, doesn't matter what it is exactly. And I consider interval from here to there, with this being the median, the middle point. For every zero I counted, maybe there was another zero here, I counted how many ones need to jump over it. Now the claim is everything on all zeros on the left from the old meeting point, they get -1 because we get rid now of this one. Maybe this is better. Copy paste. Now we move interval to here. Meeting point gets there. All these ones get -1. I'm not sure about this thing because now it was on the right, now it is on the left. But all zeros on the right, they get +1. So I would say this. Using prefix sums, we can know efficiently the number of zeros in the left part. Let's say there are 7 zeros. Each of them gets -1 to the answer, so we say that the answer, best answer for this, best score or number of moves for this interval, gets now decreased by 7. But here we see there are 5 zeros. Then it's +5. And maybe we need to do something special about those zeros between old meeting point, which was here, and new meeting point. That's my idea. We can avoid prefix sums by maintaining some stuff, maintaining the number of zeros in the left part, in the right part, but I think prefix sums are easier. It became very complicated. Won't each one have to jump median minus current minus, which can be done in constant time? Sahil Rocks, your comment seems complicated. Yes, I agree. This was my first idea when I said that once they need to travel to particular positions, like here, 3, 4, 5, 6, 7. Everything needs to kind of neighbor with median. But I'm investigating some other idea. I will not talk about New Year resolutions in middle of solving a hard problem. I'm confused. Can you recap the solution? I'm confused too, so don't worry. I mean, I described something that is... I skipped the thing about what happens with this 0 that is between old meeting position and new meeting position. I also don't talk about what happens if the number of ones is even, then the median is more of interval of possible ones. But I want to know if this is, if I should do something simpler. How to check that? I want an editorial. I think I need to find this problem in the list of problems. Like that. Solution is not here. Discuss. Using sliding window to calculate the cost of every consecutive k1s. Record their positions. If k is this. Okay, they use the first method, where if we know that meeting point should be at 4, everything needs to surround it. So if meeting point is at 4, all ones need to get to 2, 3, 4, 5, 6. Okay, this is what I saw as the first solution, and I thought it's complicated enough. I understand those formulas because they are quite common, let's say, in competitive programming. But I thought there is something simpler. That's one ugly problem then. It's hard to believe it would be used in a coding interview. What now? Okay, I will tell you shortly what's this first solution, so also the one described in the first of discussion posts. I will copy this part. No, not this. Remove that. This. Okay. What do we see on this drawing? If we want to get those together, they will meet at position 5 and surrounding positions, so at 3, 4, 5, 6, 7. Right. How to compute that efficiently? Let's for a moment assume that instead of moving to this, we actually move all of them exactly to position 5. Then I need to know the number of moves to get it like that. 5 minus 0 plus 5 minus 3, so this, plus that plus that. Let's transform this a little bit. Everything here on the left was of form 5 minus this number. So it's 5 times the count, how many numbers there are here. In this case, count is 2. Minus the sum of those numbers on the left. We had 5 minus 0 and 5 minus 3. That's in total twice 5 minus 0 and 3. Plus same stuff on the right. We have sum of values minus the count of values multiplied by 5. And each of those terms, it is easy to maintain it as we move with sliding window to the right, but also we can use prefix sums for that. You can once compute prefix sums and then efficiently ask about sum of values in some interval. Can you use his picture? It looked easy. Did it look easy? That post was quite long. So yeah. From if one's at positions 0, 2, 4, 6, 7 want to meet at median, which is the best, so at 4, 4, 4, 4, 4, we need to compute. I wouldn't say it's easy, it's a lot of stuff. We need to compute distance to get from 0, 2 to 4, 4. And I'm sure here they transform that similarly to what I did. I don't want to go through all of those. I would need to first read and exactly understand. I know a solution that is either the same or very, very similar. So let me finish talking about it. All right, but actually we want to move to this. So we unnecessarily moved from 0 to 5 while it was enough to get to 3. So I need to say this red sum, I need to update by saying -2, because 2 moves were unnecessary from 3 to 5. And -1 from 4 to 5. And same stuff on the right. And unnecessarily I went from 6 to 5 and from 9 to 5 when this was enough. And in general, this yellow thing, this difference between 5s and this arithmetic sequence, it can be expressed as minus twice 1 plus 2 plus and so on up to the count. Count is the number of elements on one side. And there is a formula for that. Okay, this is just a general version of what I wrote here. And yep, that's the answer. This minus that is the score, smallest number of moves for this window. Then we can move window by 1 and again consider it by checking new sum L and sum R. Sorry, I thought that colorful means easy. That's not the case. But of course, if somebody prepares drawings in advance, that will often be better explained than what I do here as I go. In general, editorials, if written by an experienced person, they are better than than streams. Live stream with solving problems will not explain to you a solution as well as a well-written editorial. Well-written editorial is better. If you want to watch the streams, you watch the streams mainly to be able to interact, suggest stuff, but also to see some, live mistakes. When I go in the wrong direction. Stuff like that is unique for streams. You shouldn't go to streams to see a solution for a problem because you are lazy to read an editorial. Is count means k? Actually, count is k over 2. Plus minus 1. Because count means the number of elements on the left from the middle. Like here, by count I mean 2, because there are 2 elements on the left from 5. And on the right part there are also 2. So count isn't k. Count is k over 2. What about even k? Yeah, then analysis here will change a little bit. It's not different enough that I should cover it now. It will be almost the same. Then you will have 6 elements, let's say. And you can meet at 6 or 8, doesn't matter. Let's say that we meet at 6. Anything in this interval is a good meeting point. And then, for a moment, we assume that everything goes to 6, 6, 6, 6, 6, 6. So we compute this here using prefix sums, the difference. Same stuff here. But also we know that actually I want to get a sequence 4, 5, 6, this thing. And here you have a difference of 1 plus 2 plus 3, and here you have 1 plus 2. See, same stuff. What if we kept a prefix sum for the number of encountered zeros? Then we should move the left part by the number of zeros on the left right. I didn't get that. Sorry. The fact that I don't see an easy solution and other people as well, then it suggests that this is the easiest solution. Let's move on. This was quite hard. Need to find another interesting problem. Something maybe not that hard. I don't know if whoever suggested this realized how difficult it was. Would you solve it during a contest? Yes. I mean, if you look at results of any Leetcode contest, top performers have around 20 minutes. If you look at any my past performance, I also have around 20 minutes. Sure. Notice that it's not that I needed here to look at editorial to know a solution. And you know, most of this time, it's not that I thought you will see a hard problem whenever you will understand that I'm solving a hard problem when I shut up for a few minutes to think about it. When I talking out loud and explaining, it means that already I know something and I just want to show it. But of course, there are problems that I cannot solve. On Tuesdays, I solve problems from AdCoder platform, and then you will see me struggle for 2 hours. Watch those. Would you take a suggestion from binary search? Yes, I would. Airplane seat shuffling. Probability. Okay, I'm thinking about it. 24 hours to solve all Leetcode problems? No. I would estimate that I need 5 minutes on average per Leetcode problem, multiplied by 1600. What's the number? Yeah, 1700. Divided by 60 minutes in an hour, that's 140 hours. That's 6 full days, each with 24 hours. Oh, I misunderstood your question. You're asking if I would solve one Leetcode problem in 24 hours. Yes, I would. Once or twice during a stream, I asked for the hardest problem, and it was some implementation mess. If I don't, regarding coming up with a solution, I think the maximum would be around 20 minutes, and implementing as well 1 hour. Yeah, I realized that he said any, not all. My bad. I will go through these that I already opened before because they were suggested earlier. The segment tree or try, same stuff. Oh, merge sort solution, right. All right. This can be done indeed with merge sort. Freedom trail. I'm closing that. Too long. Too simple now, it seems. Next product, too ugly. We can do this easy DP problem. We can do merge sort thing. Or binary search probability. Let's see. A first person takes a random seat. Everyone else still has their ticket, but if their seat is already taken, they will also randomly pick an available seat. Probability that the last person gets their assigned seat. We'll do a poll. We'll do a poll between merge sort thing, DP, and probability. Maybe stropple.me started working. Yep, it did. Easy DP, merge sort, count smaller, or probability. Here you go. Can you? Oh, you cannot. Wait. Okay, sorry. Again, is it DP, merge sort, count smaller, and probability. You can mark multiple. So forget about the previous one. The good stropple is the one where you can mark multiple, the one with link ending with 89. Did you skip my problem, by the way? Maybe. I mean, there are tens of suggestions. What makes a Grandmaster better than a regular red on code forces? Rating? What is your question? My problem is max product. Oh yeah, yeah, I disregarded it. I said something like, oh, maybe not. I don't know. It is more ugly than interesting, I would say. Quick add. This is my streaming schedule. You can follow Google Calendar. Add to your calendar. Wait, why doesn't it work? Okay, calendar works. I thought that schedule is alternative command for the same. And join the Discord server. Results. Let's do probability. Maybe I should have done something extra. Oh, 47 votes. That says something, right? No, this is just the sum of votes. So nobody used multi-voting, or just this is stupid count. What makes something like tourist win more? He's better. What makes, I don't know, Usain Bolt faster? He's better. Probability. This time we take problem from binarysearch.com. What makes Cristiano Ronaldo better than an average football player? He's better, that's it. You can say a lot of things like he's faster, more accurate, or maybe he has better stamina. However you want to call it. The same stuff will be for programming, just different words. All right. There are n seats. Let's say there are 5 or 4. The first person, instead of taking the first seat, he takes a random seat. If he takes the first seat, then everything else, every next person will just take a proper place. Everything will be good. But otherwise, let's say that 1 sat down on place 3. Then 2 will come. 2 will get a proper position. 3 will come and randomly will take 4th or 1st seat. Is this proper logic? I think it is. And it's up to 100,000. More time put into the game. Well, that's a good thing to say. What's the reason? How he got so good? Why don't you use the arrangement formula in this problem? Why do I? This is not... In this problem, it's not that we count permutations or anything like that. We have some more complicated process. For every new element, this is the process. First number is random. Then the next number, it's 2 if 2 is available, and otherwise a random number. Then here we have 3 if it's available, and otherwise a random number. 4 if it's available, and otherwise a random number. Whenever we have a new random number, it means that something from the past took our spot. So it seems that we often, when we move forward, we can have at most one random number still ready to take some seat. Is that true? So when this started for first 4 people, it's not that 2 of them still didn't sit. In particular, if this 4th person sat down on a random seat and it turned out to be seat 1, then this is like a proper cycle, and then everybody else will be on proper seats. Or maybe the seat of 4 was taken, so now 4 sits on a random place. It will be one of those, and that's it. Because apparently 3 sat down on position of 4. At the end, if I write down the sequence like that, it means exactly that 1 sat down on position of 3, 3 on position of 4, 4 on 6, 6 on 8, 8 on 1. Are they coming in order? It's not said, but I assume so. People from 2 to n are symmetrical, so I will assume so. It doesn't hurt. Can you explain the problem briefly? You see a statement here, right? So even if you have just joined, you can read it. When there's such small tests, very often answer is very simple, like 1 over n. Actually, without thinking more, let's try it. I have no idea why this would be true, but that's just a guess. No. Expected half, okay. Correct. In other words, we return, if n is 1, we return 1, otherwise we return half. That's quite a simple code, but that's only like one step. Let's try to understand. If n was at least 2, then return half would be a correct code. You know, for almost anything you can joke that either it happens or not, so 50% probability. What's the probability that you will be struck by lightning? You will or you will not. 2 possibilities, so 50%. Maybe same logic applies here. Probability and combinatorics are very nice category of math, where sometimes the hardest part is to understand how simple the answer is. Oh, don't worry about this. Just there will be for sure a lot of ties. My experience in Facebook Hacker Cup. I made videos for that, so you can watch them. I'm happy about my strategy. If I did F correctly, at the end I would win. For the first person, he takes a random spot. Then the second person, there are n spots. With probability 1 over n, first person takes first seat, so then everybody gets a proper seat, kind of end. Then, with probability 1 over n, first person took seat of second person, and second person will take random seat. Possibly seat of person 1, and that would also be the end. I'm not sure here. I want to do it with as simple math as possible without talking about some kind of permutations. The permutations are a very complicated topic in math. There are so many things you can do about them, to count them. Let's try to understand in which scenario we get to the end and we take spot of the last person. There is 1 over n probability that first person takes the last seat. And that's kind of the end, because for sure the last person cannot sit there. Then, what's the probability that second person will take this seat? 1 over n, that first person takes seat of person 2. Then 1 over n minus 1, that second person then takes your place. That's ugly. Can we make two cases? Sits at right place or sits at wrong place? I mean, yeah, for the first person, there are two cases. Sits at right place or wrong place. How do you activate dark mode? It's a plugin, some Chrome plugin. At least one person sits in the right place? That's not true. Maybe first sits on 2, 2 on 3, 3 on 4, 4 on 1. Okay, let's think about it differently. After the first person sits down, there is probability 1 over n that this is the end because he sat on the proper place, n minus 1 over n that random future place. Then we look at second position, second seat. We have this probability that this guy was on a random place. And now, well, out of this, first person sits on one random place out of n minus 1. With this probability, he sits on the second place, and then 2 will sit on a random place. In particular, with this probability, He will move forward instead of taking place of person 1. Plus, this is probability that first person doesn't take seat 2, but takes one of future seats. Let's simplify this. We have 1 over... The second part is easy to simplify. This is n minus 2 over n plus, and this thing is more complicated. I think it's that. No, this cannot be n. Something's wrong. Or is it? It is, because this is bigger than 1, possibly. This cancels with that. Oh yeah, n is divided. Divided by n, divided by that. Oh, so, but this can be expressed in a bit different way, right? Or it is, okay, this is equal to n minus 2 over n plus 1 times 1 divided by this. Now that multiplied. Now this is n minus 1 minus n minus 1 plus this. N divided by n minus 1. N gets cancelled and we get n minus 2 divided by n minus 1. We got this simplified form, and it was very boring. When the last person got to choose the last seat, I guess only 2 seats are available, so probability is always 0.5. I mean, you don't know if seat n is available then. Maybe it's a good way to think about it. Somebody maybe already taken the seat n. When person n sits down, there is 1 seat available. When person n minus 1 sits down, there are 2 places available, but this person prefers place n minus 1. So when n minus 1 and n minus 2 are available, he takes this one. We cannot say that because of that it's 50%. Is there another example here? Well, I already know the proper code. This is proper code. It got accepted. Last person can't choose. Second last person can, but I don't see how this gives us anything. Because people are symmetrical from 2 to n, maybe it's good to, after we say that person 1 sits on seat 4, let's see what will happen with person 4. They will for sure get a random seat. This maybe changes the answer, I don't know. So 1 sits on 4, then I look at what happens with person 4. Let's say they sit on seat 2. But isn't that the case that seat 2, person 2 would enter first? So 4 can take only some future place, seat or seat 1. And eventually maybe 7 sits down on seat 1. Everybody else would sit on proper place. How is this problem medium? Well, no, you can solve it in 15 seconds. Big persons taking 2 seats. I think it would make the problem a bit harder. Are there editors if I need something? They are. I will think for 2 or 3 more minutes, then we'll just try to submit. I did. I got accepted. This is correct code. It's kind of bluffing indeed. It's not illegal. But I would say it's more like a math problem in high school where you get extra classes to prepare for Olympiad, or just in university. I wouldn't say it's a good coding interview problem. I see how to do it in linear time with DP, by the way, but where we, after considering first k people, we just know what's the probability that they were assigned properly. Is this how you generally solve problems? Not always. I guess that the answer is just, 2 lines of code. We can go like when 0 person miss the seats, plus 2 person miss, plus 3, plus 4. Music, I didn't get that. Wow. We have a host for 300 viewers. What is that? Thank you, Lunatic. I'm doing coding interview problems, and I'm wondering why this very, very short code solves properly this very hard problem. And I can look at the tutorial, but for some more minutes, I'm trying myself. Generally today I solved problems from Leetcode. This one is not from Leetcode. I wonder if that's my max viewers then. Anyway. What was the DP state you were describing earlier? This is after people 1 to 3 sit down, what is the probability that they already take up places 1 through 3? We start with dp of 1 is 1 over n. This is probability that person 1 sat down on seat 1. Then for every next I don't want new problem suggestions now. I'm in the middle of solving this one. And yeah, after dp of I, dp of I plus 1 is either dp of I, that if already people 1 through 5 sat down properly, then person 6 will sit down properly. But also, there is probability that they didn't sit properly, and whoever now waits for a random place will sit down here. That's the probability for that is something like n 1 over n minus I. Out of places, out of seats from I forward, we take a random one. That's the probability that he sits here. Now I sit randomly, and probability that I will sit on seat 1. Also something like that. Maybe it should be like +1 here, I don't know. And at the end you print dp of n is probability that dp of n minus 1 is probability that everybody from 1 to n minus 1 sits properly. It's on Leetcode too? Well, didn't know that. All right, it's indeed the same. Is the wording the same? The first person has lost their ticket. Which was first? I guess Leetcode, right? No solution for this question. Okay. If this didn't work, then I would implement that. But let's see the editorial. I mean, for sure, from this, some recursive solution will be apparent. Okay. Proof. That's very complicated proof. I thought that the proof will be very easy. Imagine a row of n seats, one indexed. Okay, maybe first, intuition. Probability that the last passenger gets their seat for a group of n passengers. Oh, okay, just for this n. We claim that P of n is this. 1 over n plus sum over smaller n and some induction. When the first passenger gets on, the first passenger must take one of the first n minus 1 seats. Okay, we say that the first passenger, if he takes the last seat, then it's already over. Otherwise, he takes one of seats 1 through n minus 1, and we have two cases. Either it's correct seat, or just it's a smaller case. This one random person moves on, we have n minus 1 left. The first passenger takes seat 1, then everything is good. If not, I see, if not, then the next person that will move strangely is a random person from 2 to n minus 1. Hence, they take average of those probabilities. Okay, I understand exactly this proof. Everything is fine. I want an easier proof. For sure it exists, come on. I solved a lot of probability and combinatorics problems, and always there was some simple explanation, if the answer is that simple. Why subscriptions not available? Because I'm not a partner or affiliate. Do people in software engineering industry even use this stuff? No. Sometimes there are like math puzzles, also in coding interviews, which maybe isn't perfect. But at least you can now go to this link and submit 2 lines of code or 1 line. Chaos in the bus, this. I will read that. So it's some kind of block with a nice proof. Solution. Final answer is half. The reasoning goes as follows. Fate of the last person is determined the moment either the first or the last seat is selected. Oh. And that's a nice proof. Yeah, thanks for watching, CSK. See ya, goodbye. That's an awesome proof. All right, first person 1 sits down somewhere, then person 2, and for everybody from 2 to n minus 1, I will do it like that. Okay. Yes, this is a good proof. Okay. There n sits. And I will say that seats 1 and 7 are special. I assume n is equal to 7, whatever. Everything else is the same in some way. When person 1 sits down somewhere, if it sits somewhere here, we still don't know what the result is. If 1 sits here, we know what happens. Like 7 wins. 7 will get its position like everything else. If 1 sits here, well, 7 lost. That's 50-50 for this first operation. Otherwise, 1 will take one of those spots, maybe here. then 2 gets itself, then 3 gets some position. Maybe it will be one of those to just postpone this decision. Maybe 3 will take this place, then 4 will take position of 6, but eventually there will be among those elements the last one that points. Right now we have edges like this, from 1 to 3, 3 to 4, 4 to 6. But eventually somebody will be out of, like, somebody will be the first element who doesn't point to something here. The first element that points to 7 or to 1. And that's 50-50. Either it will point like that or like this. The probabilities are the same. So 50%. Right. Thank you, Dramil, for providing a nice proof. And I saw your link earlier. I just thought back then that editorial in the website will be as good. Well, actually, this is also the same thing. If they pick first, you win. If they pick last, you lose. Otherwise, the problem turns into solve of n-1. I don't agree with that. It turns into a random out of n-1 or n-2 or up to 2. So this is not true. This proof is not correct. It's close to being correct. Yeah, that's DP solution. But can't person 2 take seat 1 and person 3 take seat n? No. If 1 took second place, so if 1 took place 2, and then 2 takes place 1, then everybody further will take its own seat because it's available. If whenever somebody takes place 1, the game is over because everybody after that will take its proper place. Thank you guys for following. NSK, Martki, thanks. Earlier, Erbsa, viewer, thanks. Gab now, thank you all. I think that will be it for this stream, even though I see that we have some new followers. Hi, everybody. This was surprisingly hard. I want to keep those streams around 2 hours. I think longer is just harder to follow. You're proposing some DP solution? Yeah, like editorial also does that. What do we have here? I believe you that this is a good DP solution. It was all about understanding why this simple like one-liner would work, because we can solve it like that. 1, 1. So this was a proper solution. I wonder if this can be done shorter. This should compile in C++. Maybe n-1. If this is not 0, then 0.5, otherwise 1. This will compile. Can we do shorter? Minimum. I don't think we can do shorter than that. Also remove white space, remove all the comments, and you have quite a short solution. All right. Thank you everybody for watching. I'm looking for somebody to raid. And that's stream over. Finished class and went to watch my stream, then looked at what he was doing and realized I suck at programming. I thought you will comment on my background. Build a custom Twitch overlay with HTML and so on. Well, that's something I need to do, not a custom one. Studying for coding interviews. Great. Because I need to here. All right. Go watch cow codes. Rate. Check out Discord server, all that stuff. See you Saturday for some Codeforces stream, and maybe tomorrow I will make a stream on code chef cheating. The thing now being hot in Codeforces. All right, see ya, bye.